All right, so you've got your MR-1 machine fully assembled at this point. Perhaps you have the enclosure on the machine, and you're ready to surface the base plate. Now, we've already got the base plate surfaced here, but in the step that you're in, the base plate wouldn't be surfaced at this moment. And in this video, we're going to be basically just doing a check on all the various systems of the machine, make sure that it's been assembled properly, making sure all our lashes are correct, making sure all the bolts and all that are tight. Because the last thing that you want to have happen is you've missed, there's a bolt that's loose somewhere, and that's causing issues in the cutting process, and you're unaware of it, and all you're aware of is, hey, my machine's acting up, what's going on here? So we're going to try to get out in front of that by just double checking to make sure that the machine has been assembled correctly. So the first step is really an easy one, and that's just taking a look at the machine and any visible bolts on the machine that you can see, that you can access. You want to check to make sure that they're tight. The most important ones, I would say, are the bearing mount bolts, making sure those are tight, the bolts that secure the y-axis rails to the rail mounts, the bolts that secure the y-axis rail stiffeners, definitely the bolts that secure the gantry to the x-axis carriage. It's easy to leave, to the y-axis carriages. It's easy to kind of accidentally leave those loose because if you'll recall from the gantry squaring process, we instruct you to loosen those bolts and then to come back and tighten them. If you forget to tighten those bolts, it's going to cause issues in the cutting. We bring that up because we've made that mistake before where we've squared a machine up in our shop, we forget to tighten those bolts and we start cutting and we're like, this isn't performing the way it should. Start tracking it down and we found that to be the case where those bolts weren't tight. Other bolts, all the bolts that you can access that are securing your linear bearings. So, these 4 bolts that you can see on the y-axis carriages on both sides, all the bolts that secure the bearings for the x-axis carriage. That includes the bolts on the lower bearing carriage mount that you access from the bottom. Check those. The 3 big cap screws that secure the lower bearing carriage mount to the x-axis carriage, motor mount motors, coupling nuts, the bolts that clamp on the motor couplers, and really just anywhere else, any other bolts that I haven't mentioned here. Just it takes minutes to go and just check, just double check. Even if you think they're tight, just go and double check and make sure that they're tight. After you get done with that, you're going to need an indicator, and we're going to start pulling on the machine and checking to make sure that our lashes are all appropriate. So I'm going to go ahead and just start on the right hand ball screw for y-axis. I'm going to put the base of my indicator here, and I'm going to sense on the end of the ball screw. Then I'm just going to push and pull on this and just double check that I've got good lash here. So I'm putting, decent amount of force. I'm pulling and then releasing and then pushing and releasing. And just to seeing how much that needle moves. And I'm seeing maybe, maybe a 1/10 or 2. That's what you want to kind of aim for here. So that looks good. I'm going to perform the same checks on the other ball screw on y-axis, and then I'll jump over to the x-axis. All right, so I just wrapped up checking the bearings on the x-axis ball screw mount. And this, again, looks really, really good. I'm getting maybe 1/10 of movement on the needle. Now, if you're checking this and you've got excessive lash, this is the time where you're going to want to go and tighten up on this nut. If you recall from a previous video, what you do there is you grab onto the ball screw with some padded pliers. Some channel locks work good here. Grab onto the ball screw and then just slowly tighten that nut. And while you're pushing and pulling to check what the lash is. We recommend, don't allow the lash to be any more than about 3/10 or so. Lower is better, obviously, for a milling machine. But the key is, if you make this too tight, that's a problem because you're going to have excessive friction, and that's going to equate to a decrease in the thrust force for each axis for machining. So it's a delicate balance. You want the least amount of lash as possible without it being too tight and causing issues elsewhere. So you aim for 1/10 is really good, but 3/10 is really where you can say, yeah, this is suitable for this machine. So with that being said, I'm going to move on to the next check, which is going to be in similar vein. I'm going to be checking the lash on the bearings for the Z-axis lead screw. It's done in the exact same fashion, except what's different about this is that we've pre-assembled this in our factory. We think we do a really good job, but it's possible that one of our technicians, may have made a mistake, and that's why it's good to just go and check this again. So I'm going to put the base on the X-axis casting, and I'm going to sense on the end of the lead screw, and then I'm going to push and pull up on the Z-axis and check what that lash is there. Okay. So I've got maybe 2/10 there. So that looks good. I'll go ahead and leave that. That's within our 3/10 requirement. The next thing I'm going to check is inside of the, if you recall from assembly, there's ball nuts for each Y-axis ball screw inside of the X-axis carriage. If you don't adequately tighten the bolt that is clamping on that forked bracket that's clamping the ball nut into the internal face of the Y-axis carriage, that can cause excessive lash. And if that's the case, if you see excessive lash in there, you're going to want to actually partially disassemble this and go and tighten that bolt, because that will obviously that excessive lash. If you have a loose ball nut in there, it's not going to do its job correctly. So to check this, I just put the magnetic base on the side. The needle on the carriage. And all I'm going to do is I'm going to pull one way and then see what it springs back to. And then I'm going to push the other way and see what it springs back to. And it looks like there's about, in that ball nut, there's probably about 3, maybe 4/10 of lash. That's within spec. So this is good. I know that that's tight. Another check that you can perform is if you take a Allen wrench, if you come around the side here, if you take an Allen wrench or a punch and you push on this pin, if that pin can be pushed out, it means that the bolt that is securing the ball nut is not tight enough. So I can just grab a Allen wrench real quick and I'll push on that. So I'm pushing on this with pretty good force here, and I can't get that to push out, which means that my ball nut is going to be clamped up nice and tight, and that's what we want. So I'll go ahead and do the same check on the other side, make sure that's tight, and then I'll come and check the ball nut on the X-axis carriage. All right, so for my last check, I've got the magnetic base on the face of the gantry, and I've got the tip of my indicator up against the back side or the front side flange of the ball nut. And all I'm going to do is I'm going to push forward and release, see what the indicator's reading, pull back and release, see what the indicator's reading, and that's going to basically give me the lash value of this ball nut. So I'll push forward first, release, pull back, release. So this one, it's probably maybe 2 or 3/10 of lash. That's within spec for these ball nuts. So this machine, I've checked everything. I've tightened all the bolts. I've checked all my bearing lashes for each axis. I've checked the ball nuts for the X-axis and then both ball nuts for the Y-axis, made sure that my lash was within spec. And by doing that, I made sure that my Y-axis ball nuts in particular were being properly clamped. And with that being said, now I've got confidence that my machine has been assembled properly. I've checked all the bolts, made sure they're all tight, and I can confidently move on and start machining on this, starting with surfacing the base plate, and then from there, doing projects.